Betty deposits $2,500 in an account earning 13.5% per annum, with interest payable every 6 months. What will be the accumulated value of the account after 3 years? So once again, we're looking at compound interest, and the table is very similar to in the previous example. But here we're compounding more often. We should end up with slightly more. Let's see if that's how it works out. So, note the calculation here. We're using the I is equal to PRT over 100 formula, and that means that R just goes in as a percentage. But note what's happening with the time. We're doing it twice a year, so the time period is 6/12 or 1/2 of a year. Now the calculation is going to be done exactly the same way as the last example. So the principal for this second period is going to be the 2,500 added to the interest that we just received, 168.75, and that gives us 2,668.75. So here we're going to have 2,668.75 multiplied by 13.5 multiplied by 6/12 all over 100. So that's 2,668.75 times 13.5 multiplied by 6/12, which is a half. I'll just put that in as 0.5 over 100, and that gives us 180.14. Now I'm going to use the whole number on the calculator display for subsequent calculations rather than my rounded figure. So our next principal is going to be that added to that. So that's going to be $2,848.89. Again, I'm going to use the whole figure when I do the next calculation. So 2,848.89 times 13.5 times 6/12 all over 100. So let's just drag that down to here. Multiplied by 13.5. Once again, 6/12 is just 0.5. And divide that by 100. And a good check that we're getting this right is that we should just see a small progression in the interest each time. So this is 192.30, and then my next principal is going to be the last principal, and we'll add the interest to that, and that's going to give me 3,041 and 19 cents. So repeating the steps, 3,041 and 19 cents multiplied by 13.5 multiplied by 6/12 all over 100. Use a fraction template, drag this value into the top, multiply by 13.5, multiply by the 0.5, divide that by 100, and that gives me 205.28. And so the next principal is the last principal. Add the interest, and that's 3,246.47, and repeat the step. 3,246.47 times 13.5 times 6/12 all over 100. So fraction template, drag this into the top, multiply by 13.5, multiply by 0.5, divided by 100, and execute that, and that's 200 and $19.14. So want that and that, giving us 3, 4, 6, 5, 61. So 3, 4, 6, 5, 61 multiplied by 13.5 multiplied by 6 over 12 all over 100. And we just need to do the calculation. So it's not good when you do that. Just try and be careful when you're dragging things around the calculator. I want to make sure it goes in the top. Times 13.5 times 0.5 all divided by 100. And that gives us $233.93 there. And so my total amount in the end is going to be this added to the interest that we just got. So that's going to be $3,699.54. Now it says which is the better investment. It should be this one. I don't remember the value from the previous example, but when you compound more often you should end up with more interest. If that's not the case, when you check the values, it means that I've got one of the two examples wrong. Now that was a long enough calculation just to go for 3 years. So you can imagine doing the same calculation for 10 years, or if we compounded monthly or even daily, how long that would take us to calculate. So is there a better way of doing it than just repeating a simple interest calculation and then increasing the principal each time? Well, yes there is. There's a compound interest formula, and we'll be looking at that in later examples.